Hello everyone, this is Dinesh Chinnathambi doing my Masters in Data Analytics at National College of Ireland. This video is to demonstrate my project done for data warehousing and business intelligence. Here I have developed a data warehouse for US Airports and Airlines. To build this data warehouse, I have used 5 data sources as an input. My first data source is from opendataorgs.com. This is a structured data set which contains the site number, latitude, longitude, facility of use of airports in USA. My second data source is from Kaggle. This is a structured data set contains the information on passengers, enplanements, arrival, departure, freight services and mail services for US airports. Here you could see. My third data source is from Statista, contains the domestic market shares of leading US airlines for the year 2018. This is a structured data source. Fourth data source is from Bureau of Transportation Statistics site. This dataset contains the complete information of airline trip details for the year 2017 and 18 with origin and destination details. My fifth data source is an unstructured data source which is extracted from PDF. This data contains the delay causes of airlines for the year 2018. This is my architectural design of my project. 3 different sources of data has been extracted and has been cleansed using R script. This cleansed data is loaded into the operational database. It is a normalized database. Data from the operational layer is loaded into the data warehouse layer using SSIS. Then the cube deployment is done. Data is finally visualized using Tableau. Let's execute the SSIS workflow. Here the R script has been automated in SSIS and we could see the successful execution of the R script. Before the data gets loaded into the staging table, the staging table is truncated using the SQL task. Here are the SQL commands. Data from different flat file sources has been loaded into the staging table is shown here. Once the data load for the staging table is completed, the transaction tables are loaded. For reusability and scalability, tables in the transaction database are dropped and recreated with primary and foreign key constraints. Here are the SQL commands for creating the tables. Before loading the data into main table, lookup tables are created. Initially, the data is loaded into the lookup tables from the staging layer is shown here. Now the main tables are loaded from the staging layer. Here is the SQL command to fetch the data from the staging layer. Data from the source are passed into the lookup task in SSIS where the incoming record is replaced by the lookup value. Finally, the data is loaded into the target table by mapping the source and the destination columns. Here we could see the data is passed through the lookup and the data gets loaded into the target table. The next container is the data warehouse container. Here the fact and the dimension tables are created. These are the SQL commands for creating the fact and the dimension table. In data warehouse layer also, lookup tables are created for loading the dimension tables. For loading the data into the dimension tables, join conditions are used in the OLEDB source editor. Here you could see. Once the data gets matched, the matched record in the join condition will be loaded into the dimension tables. Here is the source and target destination column mapping is shown here. Once the data load for the dimension tables are completed, the fact tables will be loaded. Here we have 4 fact tables. Join conditions are used for loading the data into the fact tables is shown here. Here also the one-to-one mapping of the source and the destination columns is shown here. Once the fact and the dimension tables data load is completed, cube deployment will be processed automatically is shown here. Here we could see the cube deployment is processed successfully without any errors. In the analysis services, we could see 4 facts and dimension tables are interconnected to form a galaxy schema. These are the tables in the galaxy schema. Let's move on to the cube deployment that has been processed in the analysis services. We could see the latest timestamp of the cube deployment got updated in the analysis services. My first BA query is to analyze the US busiest airport based on the facility of use, passenger count, and freight services in the airport. There are different facility of usage of airports by Air Force, Navy, military, private, and public sectors. Considering the facility of use, public airports are more in number, which is shown in the bar graph. Using the passenger count, Atlanta Airport is the busiest airport, which is a public facility of use, shown in the US map. Considering the freight services, Louisville is the busiest airport, which is also a public facility of use, shown in the tree map. My second BI query is to investigate the US airline revenue and passengers per mile based on the number of passengers and distance traveled by each airline. For this visualization, I have used butterfly chart. We could see American Airlines has a passenger count of 154 million with 47 million miles traveled in the year 2017. It clearly shows that American Airlines have a high total revenue and passenger per mile when compared with others. My third BA query is to examine the best on-time arrival performance of airline and its delay causes. Out of 7,159 trips made by the Hawaiian Airlines, 6,500 times they have made on-time arrival of 91% overall and ranks number 1 in 2018. They have less departure delay and minimum flying hours to give the best on-time arrival when compared with other airlines. In this visualization, I have used line graph, bar graph, and area graph. My fourth BI query is to determine how domestic share is reliant on the employee and the passengers traveling on the airline. Airline domestic share is reliant on the better service provided by the employees and the satisfaction of the passengers traveling in the airline. We could infer that American Airlines has the best domestic share value of 17.90% with an employee count of over 100,000 and passenger count more than 144 million. This is the end of my project. Thanks for your valuable time.